This is Geometry Homework Section 14.3, Finding Areas of Trapezoids, Kites, and Rhombi. Supposed to draw the picture, find the area, label your answer. It looks like that's a picture of a trapezoid. Trapezoid, yeah, with bases 2 and 8 and an altitude of 9. So it was not specific in this picture which letters go where. So as long as you put them in order, it doesn't matter where you start. It says one base is 12, one base is 8. The bases are the parallel sides in a trapezoid. And the altitude, which is also a height, is perpendicular to the bases. It says that's 9 feet. They're all in feet. The area of a trapezoid is half the sum of the bases times the height. The bases are 8 and 12. The height is a 9er. That's half of 20 times 9. That's 10 times 9, which is 90. Supposed to label our answer. The units would be square feet because the linear units were in feet. Number 2. Kite math with a diagonal of 7.2 and a diagonal of 10.4. A kite has a pair of sides that are the same length and they're adjacent to each other, and another pair of sides are the same length and they're adjacent to each other. You can label around this any way you want because it doesn't tell us the relationships of the letters. We just know we have to go in the same order. One of the diagonals is 10.4. The other one is 7.2. It's pretty hard to label that. I'll try. The area of a kite is 1/2 the product of the diagonals. Our diagonals are 10.4 and 7.2. If you multiply those together with the calculator, you're going to get 37.44 centimeters. Number 3, find the area of each. So the picture's already drawn for us. And we have to label our answer. That means use the proper unis. To find the area of a trapezoid, it's 1/2 the sum of the bases times the height. Bases are the parallel sides, and the height is perpendicular to those bases. So it's half of 7.2 plus 2 times the height of 4. That's half of 9.2 times 4. Let me just throw that in my calculator real quick because I think it's wrong on my paper. Get 18.4. I'd written something wrong on my paper, but still got the right answer. So 2 wrongs make a right, apparently. The area of this trapezoid is 18.4 square kilometers. Number 4, this is a kite, it says. To find the area of a kite, it's half the product of the diagonals. One of the diagonals is 4 plus 2, which is 6. The other one is 3 plus 3, which is also 6. So that's going to be half of 36, that's 18. The units are square meters. Number 5, it says it's a rhombus. And boy, they don't give us much information, do they? A fact about rhombi, the diagonals are perpendicular to each other. That happens every time. So if this angle is 60 degrees, that means this one has to be 30. Opposite 30 is 4, this shows. That's the short leg. The long leg is 4 square roots of 3. And now we have enough information to do this. So area of a rhombus is 1/2 the product of the diagonals. One of the diagonals is 4 plus 4. The other one is 4 square roots of 3 plus 4 square roots of 3, which is 8 square roots of 3. That's 1/2 of 8 times 8. That's going to be 32 square roots of 3, and the units are square meters. Number 6 is also a rhombus. We are not so fortunate to have a special right triangle, so this is going to take some work for us. So big picture-wise, the area of this rhombus is 1/2 diagonal 1 times diagonal 2. We don't know either. In a rhombus, the diagonals are always perpendicular. So we can use this right triangle and right angle trig to figure out what we'll call this x is and what this is we'll call y. Actually, just throw this inside there. We could say that sine of 35 degrees is the opposite leg over the hypotenuse. And we could also say that cosine of 35 degrees is the adjacent leg over the hypotenuse. By doing that, we can figure out what x and y are, which are half the diagonals. If we solve this first equation, by multiplying both sides by 20, using a calculator, I got 11.47 is the approximate length of y. If that's the length of y, then one of the diagonals is going to be twice that, which would be 22.94. This other equation, if I multiply both sides by 20, and then throw this into my calculator, I'm going to get 16.38. And then the second diagonal is going to be twice that. And that's 32.76. So we had to do this, and we had to do this to find this area. So one diagonal is 22.94. The other is 32.76. That product is 375.76. The unis are square inches. That's a pretty tough problem. Nothing you can't handle. Number 7. Well, these appear to be the parallel sides of this trapezoid. The area of a trapezoid is 1/2 the sum of the bases times the height. The bases are 4.3 and 10.9. The height's 3.4. 4.3 and 10.9 is 15.2. That product is 25.84. The unis were yards, so it's square yards. Number 8, it's a kite. In a kite, one diagonal is bisected. So one of these diagonals is 12, is 24, I should say. The area of a kite is 1/2 diagonal 1 times diagonal 2. One diagonal is 24. Don't know what the other one is yet. We know part of it's 25. In a kite, the diagonals are always perpendicular. So that makes this a right triangle. Specifically, it makes it a Pythagorean triple. That's a 5, 12, 13. So if that's 5, 25, and 5 is 30, the other diagonal is 30. That makes this 360 square inches. on the back side. Number 9, the area of a trapezoid is half the sum of the bases times the height. The bases are the parallel sides, which are 6 and 20. The height is perpendicular to that, and we don't know what that is. But we do have this convenient right triangle. Oh, it's even more convenient. It's a 30, 60, 90. The hypotenuse is 2 times the short leg in a 30, 60, 90, which means the short leg has to be 6, which means h is 6. So the height of this little fella is 6. This is a 30, 60, 90. 6 plus 20 is 26. Half of 26 is 13. 13 times 6 is 78. The unis here are meters, so it's square meters. Number 10, rhombus. Rhombus is 1/2 the product of the diagonals. And we don't know one of the diagonals, but we do know the other. We know one of them's 4. I'm sorry, it's not 4. It's 4 plus 4. So one of these is 8. The other one, boy, not being easy on you here, are we? So a right triangle, the diagonals of a rhombus are always perpendicular. That makes this a right triangle, and let's say that we're trying to find this y value here. Using right angle trig, we could say that tangent of 28 degrees is the opposite leg over the adjacent leg. And if we multiply both sides by y, and then divide both sides by tangent of 28, put that in your calculator, you're going to get that that y value is about 7.52. That's just part of the diagonal. To find the whole thing, we're going to have to double that. So that's 15.04. So one diagonal was 8. The other one was 15.04. Half of 8's 4. 4 times 15.04 would be 60.16 square inches. Guess what's not going to go away? Trigonometry, special right triangles. Find the missing measurement, round to the 10th. So this is a trapezoid, clearly it says that. These are the bases, the parallel sides. The area of a trapezoid is 1/2 the sum of the bases times the height. Do we know what the area is? We sure do. Do we know what the sum of the bases are? No. Do we know what the bases are? Yes. 10.1 and 3.9. Do we know what the height is? No. 10.1 and 3.9 is going to be 14. Half of 14 is 7. You divide both sides by 7, you get 3. The height's 3 meters. 12, got a kite. Gotta be careful about this because it's not asking for an entire diagonal, it's asking for half a diagonal. In a kite, the diagonals are always perpendicular, and one diagonal is cut in half, the other one is not. To find the area of a kite, it's 1/2 the product of the diagonals. We know what the area is. It's 182. One of the diagonal is 18 plus 4, which is 22. And we don't know the other diagonal. It's going to be 11 times diagonal 2 is 182. which is going to make, if you divide by 11, a diagonal 2, 16.55. We are looking for the question mark in the picture, which is half a diagonal. We'll call this x. So half of 16.55 is 8.27 units of centimeters. 13. These are the parallel sides. Area of a trapezoid is 1/2 the sum of the bases times the height. The bases are 4.5 and we don't know. The height is 8.7 and the area is 62.6. Instead of me distributing this 1/2 and making that variable more complicated, I'm going to multiply both sides by 2 right now. There's only 2 terms in this problem, one on the left and one on the right. The left side we would get 125.2. The right 2 times 1/2 cancels, and we would get 4.5 plus the base 2 times 8.7. Then if I divide both sides by 8.7, I think I get kind of a mess. I don't want a mess, so I'm just going to write it as divided by 8.7. I'm going to subtract 4.5 from both sides. So that's what base 2 is. If you want an approximate answer, then put that in your calculator. I got 9.89 yards for that second base. We've got some algebra review problems we will go through. Solving this inequality. Instead of distributing the 5 once again, I'm just going to divide both sides by 5 right away. That's going to give me 3 minus 2x is less than or equal to -7. Then I'm going to subtract 3 from both sides. And then I'm going to divide each side by a negative number, which changes the inequality sign around. So I got x is greater than or equal to 5. Equal to means closed circle. Greater than means we shade to the right. So one below. I'm going to subtract 8x from both sides. I'm going to subtract 5 from both sides. I'm going to divide both sides by -4. I divided both sides by a negative number, so the inequality changes direction. So I got x is less than 6. It's an open circle at 6. Less than means we shade to the left. Graphing equations and inequalities, getting it in slope-intercept form is usually the nicest thing to do. The y-intercept is 2. The slope is -1. So that means we go down 1 to the right 1, or up 1 to the left 1. So it looks something like this. This one below it, going to get it in slope-intercept form. I'm dividing by a negative number, so the inequality sign changes direction. And then the y-intercept's -5, the slope is 2. You got to be careful with this one because it says y is greater than. That means we have to use a dashed boundary. And it's y is greater than, which is above. There's no equal to, that's why it's dashed. Greater than is shading above. Last 2 problems was to multiply this out. So 2x times 3x is 6x squared. 2x times minus 3 is a minus 6x. Negative 5 times 3x is negative 15x. Negative 5 times negative 3 is a positive 15. Combine like terms, we get 6x squared minus 21x plus 15. This next one, it's a trinomial. Lead coefficient's not 1, so we need to split the middle term and factor by grouping. We need two things that multiply to get 2x squared times 3. That's 6x squared. Two things, same two numbers add to get negative 7x. What could those numbers be? How about a negative 6x and a negative x? When you group these together, use brackets like this. There's not really brackets. Use the little things that I use. Don't actually put them in grouping symbols because your signs are going to get jacked. GCF of the first group is 2x, leaving us with x minus 3. GCF of the next group is a negative 1, leaving us with x minus 3. These two terms, there's only two terms now in the problem, have a GCF, greatest common factor, of x minus 3, leaving us with the 2x minus 1. Fully factored. Dunsies.